So, we're starting chapter 6, which means we skipped chapter 5. But we're going to come back to it week after next. So this week and next week we're going to talk about parts of chapter 6. And then the schedule has us going back to chapter 5 and finishing chapter 4. So it's not in order. But at any rate, this is the design stage of things. And I think I mentioned before, in today's world, what we want to do is design in modules. Because our software supports modules, I guess in the old world we would have called them external subroutines, but even that wasn't sufficient for what we're doing with modules. So we're going to talk a lot about modules tonight. The other thing that comes in when we talk about modules is Agile programming. Have you all heard of Agile? Yeah, okay, good. We were talking about that in our meeting, department meeting this morning, that a lot of hiring personnel, hiring managers are asking students if they understand Agile. And we need to start changing some of the names on our courses because we're teaching Agile, but we don't have the name Agile in the course name. So when a hiring person sees a transcript, and as you all know, they see the transcript long before they give you an interview. So you can't straighten out what's not on the transcript. So we've got things like component programming. Well, component is a term that fits the same thing, but it's a 10-year-old term. So we're going to start changing the names of some of our courses. But anyway, Agile is going to be something we're going to study in this class later on. So, what we're looking at tonight, I'm going to try to get through 6.3 tonight, because that's the meat of it. We're going to talk about object-oriented design, designing principles and design methodologies, of which Agile becomes in there, but this chapter doesn't talk about it. Okay, so let's get started. So, as you look at the way that your particular organization designs things, and that's what's been really the important thing. You need to know what your organization does. And if you change to a different company or a different governmental group or whatever, a different IT area, you need to early on find out what their methodologies are, because those are the ones you want to stick with. But they need to be revisited and revised, because as we get new technologies, then we need to relook at our methodologies, make sure we're not designing to old legacy systems when in fact things have changed. And that's what Agile and Modular both refer to, are new things. So refactoring. So we look at the old stuff, and periodically, if we're going to start using new technologies, we may need to do some rethinking of the way we've done things and refactor it. And of course, the whole idea is that all of these new technologies simplify our life, because we can do things we couldn't do before. So what these are guidelines for decomposing. Decomposing, we talked about before, that's where you take your requirements and you organize them and you group them into different groups of things that are related requirements. And those related requirements are decomposing. In other words, requirements as they're given to you is just a list of stuff. And we got to organize them, so put them into things. Well, what that's going to mean when we get to programming is that we may be able to put 2 or 3 requirements in the same module. But it's certainly going to have to do with how our modules relate. So, 6 dominant principles in there are modularity, interfaces, information hiding, incremental development, abstraction, and generality. So we're going to talk about all of those, or at least most of those tonight. So what is modularity? Modularity says that if you could do one requirement per module, in other words, a program to do or meet one requirement, that would be kind of like the ultimate. But it's not always a good idea because you don't want to have a zillion modules. But it's kind of, you want to get as close to one as possible. And the reason you want to do that is that we know requirements change. So over time, when requirements change, you can go to one module to change. You don't have to go through a long program list looking for where do we change things here. Nor do you have to worry about having to change it in 4 or 5 different places. So as much as possible, when you know your decomposition of requirements, you then can go into the module building, or at least designing, and say this module is going to do this requirement, etc. So, single purpose. It's easier to locate faults. When you find a fault in your system, and we're going to talk about faults not tonight, but it's later on. But a fault can be a bug in the system, or it can be that we misunderstood the requirement and we satisfied it wrong. Or we wrote a control in that said we only allow up to 10,000 as a number for this particular field, and the customer says, oh no, we can go well above that, so we got to change it, right? You don't want to change it in one place though, not in several places. Yeah, so the same thing we've been saying. Now, we're going to look at coupling and cohesion. That's how we measure how well we're doing with independence. So what is coupling? Coupling has to do with the modules themselves and how well they relate to each other. Okay? So loosely coupled modules have some dependence on other modules, but their interconnections are weak. So that means that they're doing most of their requirement internal. It's what we would call black box. You put some stuff in and you get what you want out, and you don't necessarily look at how it's doing it. Okay? Uncoupled modules have no interconnections at all, so they are the ultimate in what's called tightly coupled. So we're trying to get, loosely coupled. We're trying to get approach as much the loosely coupled as possible, which means that the module is doing the work, and it's not having to go to 2 or 3 other modules to get it done. So one requirement to one module. What about content coupling? So content coupling has to do when you have a module that gets down to a certain point, but it calls another module and changes the content of that module, or vice versa. What it finds in that module changes the content in your module. So you can say in your module, if so-and-so, then use this track in the module. If it's something else, use another. So an example of this is you're going through the program that you're working on, the pizza program. And within that, you may have modules that are dealing with giving information back to the counter clerk who's putting in orders, right? Or the manager who's looking at analyzing history of orders and inventory. And so in a particular module, it may change its content based on the user ID. if the user is a counter person, it leaves out some of the content in this module because that person doesn't have authority to do that or to reach that particular part of the module. Does that make sense? So that's what they're talking about with content changing. So content may change because of something external to the module, and it actually run differently.
What about the other one? Branches into the middle of?
Go back here. Yeah. So that's when, let's say that it knows who the user ID is, but it doesn't know the user's job. So it goes out to a module, and I've thought about this with many programs and applications that I've written, and I look at all of the file I/O work that I do within one to the same records in the same file. If I were to write modules that did nothing but control all the I/O to the database, then if anything changed in the database, it'd be that one module, change it, and everything's done, right? So let's say we did that. It's not always possible to do it that way, but that's just an example. So let's say we did that. So I'm going down through my module that has content that is for the counter clerk and for the manager. And so I see that this person's user ID is something, but I don't know what their job responsibility is. So I go over to my database application. It goes out, it comes back and says, oh, that's a counter person. That changes the content of this one. Does that make sense? So it's where you're actually, it's what we used to call an external subroutine.
Is it like if I say, you know, this is the ID, and then there's a case statement over there, and it looks up what that person's name is for that ID, and then passes it back.
Mm-hmm.
You're saying what I should do is it does something for that person ID.
Yes.
And in terms of result, you're saying I should do the branching over here.
You might.
Okay.
You might. That's
If you do the branching over in module D, then that's coupled. It's coupled to that
That's correct.
content.
And that's kind of tightly coupled, isn't it? But that's content coupling.
You're asking module D to do part of your job for you.
That's correct. And there may be a good reason for that, because what module D does may be something I can reuse for many other areas of my application, so I program it once. Yeah.
So it's good for reuse purposes.
Absolutely. It's good for error tracking. It's good for change tracking. If I need to change something in my application. I mean, you can imagine there's many areas in that, in the programming of the internal operations of the F-35, I guess is the current thing, because there are commonalities among several different things that are going on, right? So if you can modularize it and something isn't working right, or something changes, we have a new instrument we're putting in which does more than the old one used to do. So how many things do I need to change in my software? Does that make sense? Maybe it's just what used to control the input and output to that old instrument. And now I've got the new instrument. Wow, maybe I just go to that one module. But what does that begin to sound like? Well, that could be like the Aryan case that we studied earlier, where they did a reuse of an old piece of software, but it was doing metric instead of American, and the rockets crashed. So there is liability in doing that, but probably not as much as rewriting from scratch, because you create errors when you do that. Right. So it's just a matter of care.
Would redundant also be one reason for it?
Yeah.
Like to avoid redundancy, meaning like if whatever you have, say, on module D, otherwise you would have to put it on the same.
And this is the way we used to program. So this is my horror story, because I've lived it, right? You find out you made an error. Now you say, how many places did I do that same thing, right? And I find 5 of the 7 of them. 2 of them are sitting out there. And it's kind of like time bombs, because maybe they're not used very much. And a month from now, somebody just follows that route and picks up that one that didn't change. And the customer always comes back and says, I thought you fixed this. I thought I did too.
I did in the other 5 places, right?
Yeah, I did the other 5. They don't like to hear that. It's like, we have no idea what you're talking about. Okay. So again, common data is another, and it's almost the same thing, but it's really just talking about the data itself. So I may be coupled because I use the same data, is really what they're saying. Okay? So I could have global data A1, A2, and A3, and I could have variables V1 and V2, and over here in component X, I change V1 to 0. Component Y increments V1, and component Z says V1 equals V2 plus A1. Well, if you change V1 to 0, you better know what these two are needing, right? Especially if they ran before you set it back to 0.
I've seen that a lot at Lockheed, where you have multiple procedures in a package, and each one of those procedures has a little chunk of changing some global variable, some output from that procedure. Is that what
That's
this is?
stressful, isn't it? Yes.
Yeah.
Yeah. Yeah. That's exactly what that is.
Okay.
That's exactly what that is. So wouldn't it be nice if you could isolate all the changes to a certain global variable into one module? Maybe not possible, but at least it's, what we're trying to do is get thoughts in our mind. These are tools we use, right, when we're designing. If it used to be that when you had a global variable that would have been used in 23 different modules, and you can reduce that to 7 or 8, well, 1 would have been nice, but 7 or 8 is better than 23. And what we're doing is we're planting these seeds to say, while you're designing, think about these things.
I did. I pulled it out, and I created a procedure. So I went through all those modules, and I figured out what it was doing to create that.
Right.
Stuck all that in one procedure. But they don't like that, because the C-130 has over a million flight hours. So it works, even if it's not organized very well. It works. So you're creating risk.
If it ain't broke, don't fix it. Is that what you're saying?
Exactly.
Yeah.
That's exactly the way it looks.
And that's probably what you hear. That's the way they talk on the floor anyway. You know what a Maytag is, don't you?
Maytag?
Yeah. You know what a Maytag is?
The washer, dryer?
No. In a manufacturing plant, what's a Maytag?
Oh.
That's a union term. That, of course, it's too well known now. But it used to be the union term for the union guy on the floor that was the agitator.
Oh, okay.
Because a Maytag is an agitator, right? Anyway, it just came up. Things bubble up somewhere. So, anyway, so what about control coupling? Well, we talked about changing a module's content by whether it was the manager or the clerk. That's also could have been done by passing control. So if V1 is a 1, it does one thing. If it's a 0, you do something else, and it's controlled by a previous module and sent to the module you have now. Okay? That's called control coupling. Okay? Does that make sense? It's where another module controls what your module is doing by passing a parameter. And then stamp coupling, it's when more than one data value is being passed. So it's a series of things, and that's probably from what you were talking about with your list too. There could be related global variables that all kind of go together as a package. That would be considered stamp data. I don't know why they use the word stamp. It would be better if they just used group. But at any rate, that's what that really means. Now, it could be more than data too, because we're talking about object-oriented. Okay, so it could be more than data. It could be actually snippets of code that you're passing. It could be other things. Okay, so what about cohesion? Well, cohesion is within a module. And so we look at different types of cohesion: coincidental, logical, temporal, procedural, communicational, functional, and formatational. And up here is low cohesion, and down here is high cohesion. Now, what I said was that high coupling was bad because that means it's very dependent on other modules, right? So you want loose coupling. That's good. Here, low cohesion is bad and high cohesion is good. That's why the arrow is going down, and the other one, the arrow is going up. So let's take a look at what those mean. So coincidental, that's the worst one. Parts within your module are unrelated to one another. What does that probably mean? That means you're probably doing some unrelated requirements with that same module, which may mean you should have split that module into two modules. Okay. Logical, parts are related only by the logic structure of the code. Well, again, we aren't looking at code, we're looking at requirements, just deciding how much we ought to do within a module. Temporal, modules, data, and functions related because they are used at the same time in an execution. This is probably important if we're doing game design, because you want very rapid response. And procedural, that's the best. Similar to temporal, and functions pertain to the same related action or purpose. So notice temporal, because it takes time to go to another module, hopefully very fast, so there's not a lot of time. So this is good. This is even the best. We want the functions, meaning requirement. Functions and requirements, by the way, relate very closely. So the functions that we are trying to do with this module pertain to the same related action or purpose. So a very strong cohesion is a module that does very few requirements. It's focused onto one. Communication means it operates on the same data set. Functional, which is ideal, all elements essential to a single function are contained in one module. If we're trying to do one module per one requirement, we don't want to go two modules for the same requirement, because we're always going to be going back and forth. So we just put a time into our system and a complexity, because when we're looking for errors, we want the error that we find that pertains to a requirement to be in a module. We don't have to search through two modules to find what caused that. And informational, we're going to talk about data abstraction in a minute, but it's a functional cohesion and data abstraction, so we'll hold that until we get there. What about the interfaces? Well, those are the things that go on between modules, right? So an interface defines what services the software unit provides, that's the output of the module, and how other units can access those services. So if another unit wants to access those services, it may need to put an input into the module and look at the output. The interface also must define what the unit requires in order to do what it needs to do, because that begins to tell us what other modules need to be feeding this module. Or maybe it just has to go to a database to get it. But knowing what needs to come in is very important to it. So it's talking about what it requires in its environment, and the environment is the application. So what's required to run this module, and what is it going to provide back to the application? To another way of saying the same thing. So as we look at this chart, we're looking at interfaces. So we've got data, we may have operations in the interfaces. And within this module, I have interface A, which does operation 1 and 2 and 3, and then it puts stuff out. But within it, we may also have interface B, operation 2 and operation 3, and put stuff out. This could be like the manager has used this application and he gets certain stuff back out. The clerk behind the counter is using this application and only gets certain things out. Does that make sense? Okay. So that's the same application. That was the thing we talked about with content earlier. Could be changed by input. So the specification, again, for the interface, describes the externally visible properties. Because what we're doing is we're looking at what's visible, what we see coming in and what we see coming out. So outside the module, if we look at it as a square, we might have module A here. We don't necessarily need to worry right now what's inside it, but we may want to know what comes into it and what comes out of it. And these are interfaces. Okay? Does that make better sense than the text up there? And in our documentation is where this is going to show up. The interface specification communicates to other systems developers everything they need to know to use our software unit. You don't necessarily need to know how I coded what's inside my module, but you know how to use it. So this becomes important when you have teams of programmers. If you have teams of programmers, all they need to know is what's expected on the input side and what do they get out on the other side to use your module. They don't need to know how you programmed it internally. Okay? Information hiding is a term used when you're looking at what's going on inside a module. The software that's what's happening inside may actually hide data representation or informational. For instance, if I want to program within my module that I look at data as integer, but what I put out can be used by any other module, then they don't care what I'm doing inside, right? As long as it's going to do what I want it to do. I may want to say, well, you know we're never going to have a string longer than 28 characters, but I'm going to use 43 characters just in case it grows someday. Okay? They don't need to be able to see that, so I can hide that data representation. And there may be an algorithm that I'm using. Others don't need to see. So it's called hidden. It doesn't mean that I'm really hiding it. It just means that I'm not broadcasting it either. It's within the module and doesn't need to be seen by others to be able to use my module. And what that means is then that the software units are loosely coupled, meaning that the number of inputs and outputs and number of other modules that I am talking to are minimized. So it doesn't matter too much about how I'm doing things internally. Now, what about incremental development? Well, with modules, we can definitely put together something that's incremental, meaning that we can assign modules in such a way that we can begin to build our application and test it and have things work before the whole thing is programmed. So we do it incrementally. And we're going to look at the use relationships, and you're going to see use diagrams later, which will show this, to decide what we want to do. For instance, what we might want to do in the pizza parlor thing is we may want to only put together the clerk's use diagram through the system and do the modules the clerk needs. And then come back and do the modules the manager needs to work on top of that. Does that make sense? Okay. And because we're doing it in modules, we're not changing any programming within the modules to get that done. So we're putting subsets of the modules together in a logical way that are related. Now, this has to do with fan in, fan out, which is looking at interfaces. So these are interfaces where these are modules. And fan in refers to the number of units that use a particular software unit. So A runs. How many modules are using A? 1, 2, 3. How many modules are using B? 1, C, 1. No, 2. 2 are using information from C. D, none. Okay. And likewise, design 2, you may have A feeding information to 1, 2, 3, 4, 5 modules, and C just run that does G. Okay. And what's the advantage of that? This one's probably going to run a lot faster than this one, isn't it? Because you look at it, maybe A is doing more than over here it was doing. But these then, except for C, these are doing terminal things. They may be feeding a screen. And it's only C that takes one more step through G to maybe update the database. But they're both usable designs. Fan out refers to the number of units used by a particular software unit. So if I look at B, how many units is it using? It's only using 1. C is using 1. So you go back the other way. Okay. So sometimes when you're looking at something like this and we start thinking about it, maybe what we want to do is split some stuff. So looking at this, we have A that supplies C, which supplies B, which supplies A. This looks like a loop problem to me, but that's the way it's working. Well, maybe what we want to do is break B into 2 modules. And now B1 feeds A, which feeds C, which feeds B2. Okay? Or maybe we want to break A into 2, and now just B1 feeds A1, A2 feeds C, which feeds B2. Yeah, sandwiching is kind of like the opposite of sandwiching it. When I look at it, I guess you would say that is sandwiching to this way, right? but that's what they're talking about when they talk about sandwiches. They're talking about things that are in between and then breaking them up. So it's to break up mutual dependencies in tightly coupled units or long dependency chains. Remember, we want loosely coupled as much as possible. So what we've done there is we've gone from tightly coupled to more loosely coupled as we go left to right. So what is abstraction? Well, as we look at what our module does, we might want to just talk about certain parts of the module at a time. So we're kind of doing abstractions within the module. And suppose that we have a function that sorts the elements of list L. The initial description might be sort L in non-descending or non-decreasing order, right? Non-decreasing. So we call that increasing. Not sure why I said that. But the next level of abstraction could be that we actually give some pseudocode into how it might work to do that. Okay. I think that's selection sort, which I teach in another course. So the algorithm provides a great deal of additional information. However, it can be made even more detailed by doing this. Okay. And basically, that's going to give you code you can almost program as is. So generality, that's what makes a design principle as universally applicable as possible. And that kind of talks about that module I suggested earlier where you have one module that maybe handles all of your database access and update operations. That's a very general because it doesn't know who's going to ask it for something. But it's one place where if there's ever an error in reading the database, you go to that one module and fix it. Or if there's a change in the database and we're adding more fields to the records in the database, then it's that one module that needs to be updated. Okay? So that refers to generality. You can't always do that, but again, all of these things are like it'd be nice to have if we can do it. So the further we can get towards these ideas, the more simplistic our coding is in the sense of ease of support and maintenance, as well as reliability. So this is just referring to generality. Now we're going to talk about next time unified modeling language, UML. UML diagrams are something that you need to do for your project, right? How many have looked at that already? A little bit? Okay. You want to do the next lecture? Or whatever. Yeah, if you wouldn't have to do the project. Yeah. Yeah, so next week we'll talk a little bit more about unified language, modeling language, and finish out what we can in Chapter 6. Okay? But I think where we are right now kind of is a good stopping point for what we did tonight. Cohesion and coupling are very important concepts. They begin to describe really what you're trying to do with modular approach, which is a strength we didn't have 10, 15 years ago. I would never have tried to do that with Fortran. Actually, there was a language back in the I shouldn't say how far back, I age myself, but anyway, back in the 70s, called APL. Have you ever heard of APL? You know what it stands for? A programming language. And it came from a master's thesis that a student did at MIT. And he was trying to describe a language that could be completely symbolic and use all 255 characters. Okay? And each character is a subroutine of itself. It means something. It's actually a routine. But because they could all be floating in memory at the same time, assuming you had enough memory, then you could write programs that ran very fast with lots of subroutines. The only problem with it is it was the furthest thing from self-documenting. Self-documenting says at least you can read somebody else's software and begin to understand what they wrote. You could never, because you could write one line, and do the whole program. And it was just a terrible thing to try to document. But it was a very effective language. So it was one of those things where it was done as a blackboard language first, meaning it just was on the blackboard for his thesis. And then IBM picked it up and made it a real language. Does everyone know that BASIC was that way too? BASIC was never meant to be a programming language. It was created at Dartmouth just to teach programming, because Fortran with its Hollerith codes was too difficult for first-year programming. Okay, so any questions about tonight? Do we have enough here to talk in your groups?
Yeah, 2 from each team.
Yeah, well,
But we don't have much to say though, so.
that's good. Yes, you feel like the teams are working okay?
Well, I missed last week, so.
Okay. Do you all have electronic communication set up? Okay. Are you using the Dropboxes, or are you doing it through some method you came up with yourselves?
No, we haven't gotten to that point yet.
Okay. So you're emailing? Okay. So that's okay too. I have a one team that's Skyping. So, yeah. So there's a number of ways you can do it. Okay. Well then, that's all I had to cover tonight. And try to get your teams here next week, because what I'm trying to do is set aside 20 to 30 minutes per class period so that you really can talk to each other about where you are. And we're in week 4, so next week will be in week 5, right? So we're almost, we really don't use all 16 weeks. In fact, I've tried to get it into 15 weeks so that we're pretty well done before Thanksgiving vacation. Because I think there's one day of class when we get back, and then finals week or something like that. And I don't like to split it up. So I want to get our test, we call it test 2 now, but it is the final. And it's take home. So I'd like to get that done before Thanksgiving, and the project's presented before Thanksgiving, and you're done. When you go home for Thanksgiving vacation, you're out. You're done. Okay? All right. Okay. And everybody's okay with what we did tonight?
Yeah.
Okay, did that add a little insight into what modules are all about and the importance of modules? That's the biggest part.
Yeah.
Okay.
Yeah.
Okay.
I'll come up to you. I'll probably just follow up email after class or whatever.
Okay.